Hello, my name is Matthew Krupsak. I am the founder and president of Theta Informatics LLC, and this video is a demo of OpenAthena Desktop version 1.0.2. This release marks a fairly major milestone for us at Theta Informatics as our first 1.0 release of the OpenAthena Desktop and core software. This software has been in development for over 6 years and counting. And this 1.0 release introduces several major new features for our users. The OpenAthena software introduces a novel terrain-raycast technique for remote sensing by drone. Essentially, for any single pixel of a single drone image frame, OpenAthena Desktop is able to range and geolocate whatever that drone camera is looking at without the use of a laser rangefinder or triangulation and mapping, as with traditional approaches. OpenAthena's terrain raycast technique essentially simulates the effect of a laser rangefinder, but in software rather than hardware, allowing any regular, cheap, inexpensive drone to range and geolocate ground objects of interest. This is extremely useful for time-sensitive situational awareness and common operating picture use cases of drones, such as for search and rescue, public safety, or defense, intelligence, surveillance, and reconnaissance applications. So instead of a laser rangefinder, OpenAthena essentially performs the same ranging calculation by simulating a raycast against a digital elevation model file, which is essentially a digital twin of the ground terrain surrounding the drone. This is an example of what one of these digital elevation model files actually looks like inside of the OpenAthena software. So this is clipped from the SRTM dataset for the area surrounding Rome, Italy. And we can see that these elevation model files are essentially a 2D bitmap similar to a digital image. Instead of color, however, each of these pixels of this image are storing the altitude of terrain in either a 30 by 30 meter area or a 10 by 10 meter area. Internally, OpenAthena automatically selects the best available terrain file for the area surrounding the drone and interpolates between these data points as it simulates that line out from the drone camera's position, orientation, and pixel within the image until it intersects with that ground terrain. Because we interpolate this data, the accuracy is often far superior than the 30 meter or 10 meter horizontal resolution would imply. So here I'm going to show an example of how we can load a drone image and get instant calculation results. So OpenAthena Desktop is compatible with a wide variety of drones made by Parrot, Skydio, DJI, Autel, and Teal. It contains a calibrations database of over 60 different drone camera models across more than 5 different manufacturers, including most EO and IR payloads on a variety of UAS. Typically, we've been able to extend compatibility for additional drone models in as little as 2 days. It's a very simple procedure we have for adding new drone camera calibrations and metadata support to our software. Okay, so now I've loaded a drone image. This was taken by our Skydio X10, and I can click any point within the image to get a ground geolocation. Now, because I haven't operated the software for this area previously, it is now downloading that terrain model for the surrounding area, which completes in a few seconds. Later, if I click elsewhere in the image, it'll be able to calculate instantly without performing a download operation. OpenAthena Desktop can operate entirely offline as long as terrain data is pre-downloaded for the area of operations. Now that I've selected a point within the image, I can see that a latitude-longitude coordinate appears, and also a NATO military grid reference coordinate as well. The software also tells me the elevation of the ground target, distance from drone to target, and some other useful info here. When ready for the indicated target, I can hit the Send Cursor on Target button up here, which will begin the process of sending a position location information message to ATAC so that it shows up as a point on the shared map and common operating picture. Just to start, I'm going to use the default details here. And then if I switch to my device running TAC in this other window, we'll be able to see the point appear on the map. We can see here in the cursor on target message that's reported, it also has an accurate estimation of the target error from the UAS platform using a target location error model that we've calibrated to the particular drone. So TAC, which is shown here, is a software product released by the United States government and TAC Product Center. It was originally created for the DoD, but is now increasingly being used by many public safety, police departments, and search and rescue practitioners. It's very accessible as a free piece of software and is extremely useful for basically a shared Google Maps-like interface. So this target symbol here in yellow is classified as unknown. But we can see here if I want to send a different point and maybe a different type of object, the OpenAthena Desktop interface supports that as well. So I've selected a different target within the image for which it's calculated location. I'm going to hit the Send COT button and then begin putting in the details of the target. OpenAthena Desktop has a extremely comprehensive list of relevant military and civilian objects that can be selected. We'll also be producing a version of the OpenAthena Desktop software with military objects removed from this list so that the software is suitable for export. Now I'm going to select the target type as ground, combat, infantry, and then light. I can put in a target ID relevant to the echelon that I'm communicating this data to. And then I can put some remarks about the indicated target. So I'm just going to write dismounted infantry stationary in the open and then send cursor on target. By default, looks like I forgot to set him to hostile. So I can select the allegiance of the entity, either unknown, friend, neutral, suspect, hostile, or non-specified are the most common. And I'm actually just going to overwrite this point here by using the same cursor on target ID. Once it is in the TAC interface, every device that received that cursor on target message is going to be able to see the same cursor on target ID, symbology according to NATO standard map icons for that type of unit, and then also in the remarks field, various other details we put in about that object. So that's the main functionality of OpenAthena's terrain-raycast engine. Something that's also new and very useful in OpenAthena Desktop 1.0 is the ability to pre-download terrain data for a large area of operations with a single operation. So essentially for that terrain data, OpenAthena needs to have terrain data for the operating area of that drone to be able to operate offline. Thankfully, these terrain data files are extremely small and can be as little as 5 kilobytes per square kilometer of coverage area. So to bulk download a large region for later offline operations, I can go into the DEMS interface here and say new bulk DEM downloader. Now I'm just going to put in 2 opposing corners of the area I want to cover. So for this example, I'm going to download the entire Atlanta metro area. I can input these coordinates as either latitude, longitude, decimal, latitude, longitude, degree, minute, second, or NATO MGRS coordinates. Here I can set the size of each DEM tile that it's going to download. In this example, I'm going to use the default of 25 kilometers width and height per DEM file. And I'm setting in overlap percentage to 20%. So that way, if we have a drone image that's taken on the edge of a DEM, it's still going to have sufficient coverage and can easily switch over if it runs out of bounds. I'm going to set the job name here to Atlanta area. And then for the data set here, I have several choices. In the US, we're going to have the best accuracy with the USGS 3DEP, which is a highly accurate bare digital terrain model that removes trees and buildings from the terrain layer. In Europe, Western Europe, the EU DTM is going to provide similar accuracy and type of coverage. And then elsewhere on the globe, we would select here the Copernicus 30 dataset, which is a global digital surface model that technically measures treetop and building top height, but in practice actually works pretty well with this technique. But yeah, since we're in the US, I'm going to get the best accuracy with 3DEP, so I'm going to select that here. And then when I click Create New Bulk Downloader, it'll automatically determine how to slice up that area into tiles and download those from the Open Topography service online. So while I have an internet connection, I can run this bulk download to prefetch an area that I know I'll be operating in later so that I can run this software without an internet connection. I can see here that it has sliced this area into 12 different tiles, and it has already completed. And if I go into the DEMS Manage DEM Cache interface, I can see a list of all the files that have been downloaded. If I am about to go offline and I want to check if I have coverage for a certain area, the DEMS interface also has an easy way to look up to see if a given spot is covered. So you can see here it tells me that there is a 3DEP DEM file for that location. So now if I load a drone image in that covered area, it'll select the best available DEM file automatically, so I don't have to think about it when running offline. OpenAthena also supports the ability to look up the terrain elevation for any arbitrary point that's covered with the terrain data. Some new features we added to the OpenAthena Core software library, which is our developer-focused product that OpenAthena Desktop is actually built on. The processing engine for terrain-raycast is now entirely multi-threaded, so it can process many requests simultaneously, and no longer stalls for location calculation requests while a terrain data download operation is ongoing. In the OpenAthena Core software module, we also added support for MISB format drone video metadata, allowing the video metadata from a variety of drone platforms to be used directly with the OpenAthena Core API. The OpenAthena Core API is a simple modular open systems architecture interface, which uses a very simple RESTful HTTP API. The specification for this API is public on our website, api.openathena.com, and it essentially details how to get OpenAthena's terrain raycast capability into your own hardware and software products. So for most of our customers who go this route, we give them a key for the online version of our OpenAthena API. And then when they get that tested and working with their platform, we issue them a copy of the offline version, OpenAthena Core, which can perform all the same capabilities shown here in OpenAthena Desktop, but as a modular software library that can even be run offline and embedded on a drone or ground control station. So it's got very, very simple call and response request format where I'm giving it the same details of a drone, mainly its position, orientation, and some camera information. And then within less than 5 milliseconds, it's performing that terrain raycast for ranging and returning the ground location result. All right, so this concludes the demo of OpenAthena Desktop version 1.0. I would highly encourage you to check out our website at openathena.com. And we are now issuing evaluation copies to end users and developers. If you go to the contact page on our website, that goes straight to us, and we'd be happy to engage with you to get this going. So thanks.